So today we're going to be looking at what conditionals are in Python and why we would ever need to use them in the first place. Your video contents, we're going to learn what conditionals are, how to use conditional operators, and most importantly, if, else, and elif statements. Actually, most importantly is practice, but the heart of decision making and conditionals are if and else statements. Those are very important. Let's get to it. How do computers make decisions? That's a pretty important question. So I want you to think for a second about how a computer can think on its own. Think about video game characters or how they can randomly run up to you and attack you. Think about the new Tesla model vehicles that can drive on their own. Think about automatic coffee machines that turn on and operate by themselves at certain times. These are all examples of a computer operating under certain conditions. Now, to answer the original question, computers do not make decisions on their own. We have to write our own code in a way that the computer must do something specific in response to a certain condition. So for example, if the milk variable, let's say we have a milk variable with a number integer assigned to it. So let's say we have milk is equivalent to 0. Well, then we want our if statement to print out he needs some milk afterwards. So we need comparison operators to start writing conditional statements. So I think I touched on what Boolean operators are in the first video about variables. We have our true and false values. These are Boolean values. We have our double equal sign. This is actually is equivalent to, less than, greater than or equal to, less than or equal to, and this is does not equal to. Here's our example over here. If we have a variable true Boolean, and we set it equal to true, we assign the true Boolean value to this variable. Well, then if we go down and call the true Boolean variable by the Python interpreter, it's going to return the true value because that's what we set the true Boolean variable to be. That's what we assigned to it. Down here, we have 25 is less than 1,000. That's true. Over here, we have 25 is greater than 1,000, and that's false. And that's pretty much how to use some of these. I advise you to mess around on your own with these. Logic operators are also extremely important. We have our and or operators. The and operator is true if both operands are true, and the or operator is true if either operands are true. So let's look at what that means in the example. Let's say we have two integer variables, a and b. A is equal to 7, b is equal to 14. So let's say we have a condition that we want to set. A is less than 10 and a is equivalent to 7. Well, look, a is less than 10 and it's equivalent to 7. So that becomes true. We have another one, a is less than 5 and a is equivalent to 7. That returns false. So when you have multiple conditions that you want set on either side, you can use and or or. Let's look at the or. A is less than 10 or a is not equal to 7. Well, this one is false, but this one is true. But remember, the or operator returns true if either side of the operands are true. So this left side is actually true. This right side is false. Let's move on. This is probably the weirdest and most important operator in computer science, I'd say, for decision making. This is called the modulo operator. I didn't include this in my first video about variables and data types because I had never seen this until I took a computer science class. This is called the modulo operator. It's the percentage sign, but this actually in Python, it returns the remainder of division. So let's say we want to do 10 modulo 1. Well, in your head, you should think 10 divided by 1. Well, there's no remainder there because 10 divided by 1 is an even division. So there's a 0 remainder. If there was a remainder, it would give you something else. 10 modulus 5. If let's say it out loud, 10 divided by 5, well, that's 2, and there's no remainder, so the remainder is 0. 10 modulus 3. You can't do 10 divided by 3 evenly. There becomes one remainder. So that's kind of how you use the modulo operator, and that becomes really important in mathematics, or think about when you're trying to figure out the factors of a number. Now, the most important part in conditionals and decision making for computers is the if, elif, and else statements. The if and elif and else statements help instruct the computer of what to do under certain conditions. The syntax for the if statement is pretty simple. You just have your if statement, your conditional or your test statement afterwards, your colon, and then you want to have a tab before your next statement or command. So let's look at our example here. Age, we have this variable, we assign it an integer value. Age is equal to 50. So let's mess around with the if, elif, and else statements. If age is less than 10, print you're a baby. So remember, in our syntax, we have our if, and then we have our conditional statement, which is going to return a true or a false Boolean value. So if this is true, it would print you're a baby. And then we have elif, age is greater than 11 and less than 20, print do you watch Twilight? And then we have if age is greater than or equal to 20 and less than 30, we can print get a job. If age is greater than or equal to 30 and less than 40, print don't forget your vitamins, because you're getting a little bit up there in the age meter. Then we have our else statement. This one doesn't have a condition. It's just known by Python to be the last thing that the interpreter would do. So if all of these fail, if all of these are false, the else statement will automatically print, wow, you're old. So think about this. We have age is equal to 50. Now, what would this print out? What would all of these, this if statement, this code that we just wrote, what would this print out? If age is equal to 50, that's right. It would print, wow, you're old, because age is equal to 50, and that's a condition that's actually false on all of these, but true here because the else statement prints it out anyways, remember? Now, the best part, let's practice. We're going to make a factor program. It's going to just give us the factors of any number we put in it, and then we're going to make a screensaver. So let's practice. So go ahead and open up a command prompt terminal session, and let's make our factors function, and let's make our screensaver. But first, let's give it some color and call Python. Python 3.7.4 is running, so we know that we're good to go. Give yourself some space and let's start coding. So we're going to make a factors list because our name is Dante's Derivatives. So this has to be a mathy channel at some point, right? So we're going to define our factors function. If you don't know what we're doing, if you don't recognize the stuff here that I'm typing, just hold tight, just type out exactly what I'm typing, and eventually in the next couple of videos, all of this will become clear, but you will recognize the if statement once we get to it. So define factors, our factors function, we got to put an input, and that input will be the number that we want to check. So like if we want to check the factors of 120, we'd put factors 120. But let's write our function first. So this function returns, put some information about our function, returns a list of factors. So we're going to create a list called factors list. It's going to be empty at first until we use a for loop. This for loop is going to run from 1 to the number that we want to check plus 1, because we want to include the number just in case the number is a factor of itself, which every number is a factor of itself. So at that point, when we're going through the list, if the number that we're checking modulus the item in the list, if there's 0 remainder, then we're going to add that item. We're going to add that item to the list. And then we're going to have our factors list of 120 or whatever number we put into it. So this function will return the factors list, whatever we've filled in it with our for loop. So this if statement, let's go back to this if statement. The number modulus item, if number modulus item is equivalent to 0, pretty much all that's saying is if there's a remainder, if there's 0 remainder, then you add that item to the list, the factors list, because if there's 0 remainder in division, that means that that's a factor you're dealing with. So let's check our factors list, 120. 1, 2, 3, 4, 5, yada, 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 all the way up to 120. So 120 actually is a factor of itself, of course. We knew that. Factors 1,000. Oop, that's 10,000. The numbers just keep getting bigger. All right, let's try. Okay, yeah, Python's pretty fast and pretty powerful. It's written by a mathematician, so you'd expect it to be, but last test, let's try and break the computer. See what happens here. It's going to take a while, but we might get something. I think we broke it. I think we broke it. If that ever happens, you can just hit something like Control-C. And that will keyboard interrupt, that will cancel whatever command is running on your Python interpreter. So let's go ahead and try and make our screensaver at this point. All right, so for the screensaver, we need to import from our turtle module because we're going to use the little turtle to draw. We're going to import everything. From the random module, we're going to import the random integer functionality. And with the turtle module stuff, I like to use the turtle shape. Give it some background color. Make your turtle color green. Got to give the turtle some width, so that way you can see the lines. And we're going to make the speed as fast as possible. 0 is the fastest possible speed. So let me show you guys what I just did. I made a little turtle appear on the screen, and he's going to move left, right, up, down, wherever he wants to go. He's going to move all around the screen after we're done with our function. Now let's go. We're going to define a function called wander. We're going to use a while true loop and move forward 3 while the loop is true, which is at all times. If our x coordinate, this is where we're using our if statement, if our x coordinate, and by the way, if you don't know your x and y coordinate systems, that's okay. Just think of it as north, south, east, and west. You're just moving to a different location, but it doesn't hurt to go and look up your two-dimensional xy coordinate system from algebra, actually. So if x coordinate is less than or equal to -400, or if the x coordinate is greater than or equal to 400, or your y coordinate is less than or equal to -400, or your y coordinate is greater than or equal to 400. If any of those are true, we're going to move left a random integer between 90 and 180, and that will be in degrees. So we never know how or what, how far left it's actually going to turn, so it can go in any direction it wants. And when we call that function the wander function, I'll pull up the screen. We got a little screensaver. I like watching this. It's pretty satisfying. If you liked what you saw, if you like learning with me, go ahead and hit that subscribe button down there a little bit and hit the like and leave me a comment. Let me know if you liked it or not. Share it with all of your friends and your grandparents especially, because they love their computers. and you guys have a great day.